So in this video we'll do an example of the hypothesis test. Let's first talk through the StatCrunch output that I have here. This is the same StatCrunch output that we needed when we just got through and did the intercept and slope when we did that equation. So just to kind of re-show you how we did that, let me delete this first. So if we go to Stat, Regression, Simple Linear, just put in our values of x and y, and hit Compute. So that's the output that we're going to be using to do the hypothesis test. So as with every hypothesis test we do, we're going to do the same 5 steps. So we're going to start with our null and alternative hypothesis. So our null hypothesis is that our y, which is points scored, is not linearly related to total yardage. While the alternative hypothesis is that points scored is linearly related to total yardage. Now up here in the problem, it told us to use a 1% significance level. So we will reject the null hypothesis and instead believe the alternative hypothesis if our p-value is less than our significance level of 1% or 0.01. Now when it comes to our conditions here in step 3, we're not going to formally check them, but we're at least going to list the conditions that we need. So we need the idea of things to be normal. So at each value of x, y is distributed normally. We need to have that same population standard deviation, and we need independence. That would sort of be the idea of that how many points scored in each game is independent of any other game. Now for our test statistic, we're calculating our t. We're doing a hypothesis test for slope. So all of the numbers I'm going to pull off are going to be from the slope row, and I don't want to accidentally jump up into that intercept row. So my estimate, my B1 that I need, is 0.0969. We're assuming a slope of 0, so no relationship, and dividing by the standard error attached to the slope, which is 0.01421. When we do that math, we should get a t close to that 6.81 that you see here as well. Now sometimes I mean to delete this number, so it's nice to know how to calculate that number as well. Alright, so for step 4, I always draw my picture. So looking at our t here. So our value of t is 6.81. So in theory, that's really far out here. Since technically my alternative is not specifying a specific direction, it's this two-tailed idea, I would technically also have way down here as well the negative 6.81, and everything to the left of that shaded, and everything to the right here. So I have this area shaded and this area shaded. So that's why what you see here, we get a really small p-value for that reason. So our p-value is so small, it's smaller than 0.0001, which then is less than our 0.01. So we are going to turn out then to reject the null hypothesis and believe the alternative hypothesis. Doing our interpretation, so our alpha is 0.01. We rejected, so there is our statistically significant evidence. To support that points scored is linearly related to total yardage. More specifically here, though, we can also then actually say that this is also in a positive manner. How do we know it's positive? Well, my slope was positive. Why was my slope positive? That affected my test statistic to be positive as well. So the fact that I fell above where I expected to be would tell me my slope is positive. If my t would have been negative, my slope would have been negative, tell me that there was a negative relationship instead. So if I do reject here, I can also figure out if it's a positive or a negative relationship. In the next video, we'll start discussing confidence intervals.